In order to rationalize the denominator when you have addition or subtraction is similar to how we rationalize the denominator with irrational numbers such as 1 over 6 plus the square root of 7. Namely, we're going to use a conjugate. So what would be the conjugate of 2 minus 3i? Well, if you remember, all you do is change the sign that's in the middle. So we're going to turn this into 2 plus 3i. And when you multiply that out, you're going to find that the outer and the inner terms cancel out. So we can multiply 2 times 2 is equal to 4. We can multiply 2 times 3i, which is 6i. We're going to multiply negative 3i and 2, which is going to be a negative 6i. And then finally, we're going to multiply the last terms, which is going to get us a minus a 9 and I squared. Now, these middle terms will always cancel out. So in all honesty, you don't need to multiply them. When you have a conjugate, all you need to do is multiply the first and then multiply the last. It makes for quicker math. So we have 4 minus 9 squared. Well, that is going to turn into 4 minus 9 times negative 1 because I squared is negative 1. And then that is going to turn into 4 plus 9, which is 13. So you've completely eliminated the imaginary part of your complex number. So we are going to try these two examples. Example C, we're going to just steal our answer here. We're going to multiply by 2 plus 3i on the top and the bottom, because remember, you're just multiplying by 1. You don't want to actually change the problem. I'm going to have 3 times 2 plus 3i. I'll worry about distributing later. And on the bottom, we found out that you only have to multiply the first and the last. So we're going to get 4 minus 9i squared. And again, we said that this I squared part is just negative 1. So what we're really doing is 4 plus 9 equals 13. So we're going to put 13 in the denominator. Now, since 3 and 13 do not cancel out, now I'm going to take the time to distribute my 3. I'm going to write this not quite in standard form. I'm going to say that this problem is 6 plus 9i all over 13. If they do not ask you to write it in standard form, it is safe to say that this is done. If they would like it in standard form, what you do is break this apart into its two pieces. 6 over 13 plus 9i over 13. So now we're going to have a similar problem where we need to get rid of 1 plus 2i in the denominator. So to eliminate that imaginary part, we're going to multiply by 1 minus 2i in the denominator and in the numerator. Except this time, we are going to FOIL this all the way out, both of them. So in the bottom, we multiply our first terms, 1. We multiply our last terms, minus 4i squared. This is going to become 1 plus 4 because, if you remember, I squared is negative 1. So negative 4 times negative 1 is going to equal plus 4. So 1 plus 4 is 5. So we have successfully made the denominator 5. What we need to do now is we need to multiply the numerator. And this one you must FOIL all the way out. For those of you who struggle with it, keeping track of everything, you could put it in a little box. We could make like a little Punnett square, and we would have 5 and a minus 2i, and we would have the 1 and the minus 2i here. And then we would just multiply. 5 times 1 is 5. 1 times negative 2i is negative
2i, 5 times negative 2i, and negative 2 and negative 2 is a 4 and an I squared. And now we can just set about collecting our like terms. So our like terms, we've got these two, negative 10i and negative 2i, is going to make negative 12i. We have a 5, and remember, I squared is negative 1, so we have 5 minus 4. And that's going to equal 1. So we have 1 minus 12i. If you are to write this in standard form, a plus bi, we need to split this up. So we're going to send a 5 to the 1 and to the negative 12. We're going to write this final form as 1/5 minus 12i over 5.